Hey everybody, Vade here. Just making a quick video going over the difference formulas for both sine and cosine. I thought I covered it in the last understanding not memorizing video, but apparently I didn't. But this is pretty straightforward, especially since we know the angle sum formulas for sine and cosine. So this is the first time in understanding not memorizing history where I'm going to ask you to actually pause the video and think about how you can do this, because I feel like it's pretty straightforward if you know those formulas and, again, understand the formulas. And you can watch the last video in the series if you don't understand it, because I think the proof for, again, it's not a completely polished proof for the sum formulas, but it is a really good proof in terms of understanding where they come from. Okay, so pause video. All right, hopefully you gave it some thought. If you're struggling, that's okay. So I kind of said, I kind of foreshadowed here that this is simple because we know the sum formulas. How can we apply the sum formulas to prove the difference formulas? Well, we can rewrite it as, if we want to find, for example, sine of a minus b, we can rewrite it as sine of a plus negative b. Cosine of a minus b, we can rewrite it as cosine of a plus negative b, right? Those are equivalent. So, and another thing is, if you're kind of thinking ahead here, which I am, again, I haven't. This is the first time I'm doing it. I didn't write the proof beforehand. I'm doing it live in front of you guys. Is that we're gonna have to use some even and odd identities here. Now, the proof for the even and odd identity should hopefully make sense just looking at the graphs of both sine and cosine, especially the parent graphs like sine of x and cosine of x. Hopefully you guys know the definition of even and odd by now. It's just like if we're looking at parent graphs with no translations, an even function is always symmetrical with respect to the y-axis, and an odd function is always symmetrical with respect to the x-axis. And over time, people found these sort of analytic techniques that we can use to determine whether a function is even or odd. And this is particularly useful in this case with sine and cosine. And again, just to recall, even is when we have, let's say we have some function f of x, f of negative x equals f of x. We have an odd function, it's f of negative x equals negative f of x. And of course, this analytic sort of, these analytic definitions here can be seen graphically. So do this test and graph the function that passes. For even test, you should see that symmetry. Odd test, you should see the symmetry of the origin. Of course, if there's translations, that's a little, assume it's parent graph is what I would say. Okay, because translations don't necessarily, they don't impact the sign when we're dealing with stuff, in this case with the argument. Anyway, so let's do sine first. So we have sine of a plus negative b. Okay, and again, you should know these formulas. I made a last video in the series, going over them. You shouldn't have to really memorize them, or at least feel like you're forced to memorize it. You should at least know where these come from. This is true for all the videos in the series. So this should be sine of a cosine of negative b plus cosine of a sine of negative b. Now here, this is where, again, we deal with the even and odd identities for sine and cosine. And again, these come from the definitions of even and odd. Trying to find my pointer. This comes from the definition. These come from the definition for even and odd, the definitions. So, again, I'm not necessarily going to go over these even and odd identities because these are sort of, again, come from these definitions, which I just explained. So, in this case, cosine of negative b, that's just the same as cosine of b. And sine of negative b, that's the same as negative sine of b. So, we want to rewrite this here. We'll get sine of a cosine of B minus cosine of A sine of B. So hopefully you notice here the signs literally just switched. Okay, and now for cosine, right? Cosine of, I'm going to write the therefore. Therefore, sine of A minus B equals sine of A cosine of B minus cosine of A sine of B. So cosine of A plus negative B equals to cosine of A cosine of negative B minus sine of A sine of negative B. So again, even not identities, this should be cosine of positive B, and this should be negative sine of B. So then we'll get cosine of A cosine of B plus sine of A sine of B. So then therefore, and again, hopefully you see it's just a sign switch. So then we can say therefore cosine of A minus B equals to cosine of A cosine of B plus sine A sine B. So yes, it's just a simple sign change, but still important to go over here, just so we know where it all comes from. It's not made up. Okay. See you guys in the next one.